Students, now it is okay, wa? The board visible.
The sound is not okay, sir.
Sir, I have echo, sir. Sound.
Now sound okay, wa?
Yes, sir, little bit.
Yeah. Now it is okay, wa? Okay, shall I start the class?
No, sir.
My voice audible or not? Hello? Students respond.
Okay, sir. Okay. Yes, sir. Yes, sir. Okay, sir.
Yes, sir, audible,
Okay.
sir.
Yeah. Okay. Shall I start the class, pa? Sorry for the delay because here some issues for that. Okay. Actually, now we move on to expectation, mean, and variance of both the variables. Okay. So actually, discrete random variable. How to define that expectation means this is the formula. Expectation of the discrete random variable is nothing but sum of the probability, sum of that. We have the data. So this is your random value of the variable. Okay. So next, this is your corresponding probability function. Okay. So now you have to multiply that value of the random variable, the corresponding probability function. Finally, it will take sum of the all the multiplication value. Okay. So this is called a expectation of the random variable. The next one is expectation of x square. Okay. So expectation of x square is nothing but we can squaring all the values of the random variable that will be multiplied with the corresponding probability values. Then finally you are taking the summation. Okay. So this is expectation of x squared. Then mean of the random variable is nothing but expectation of x. Okay. Variance of the random variable is expectation of x squared minus expectation of x whole squared. So these are the formulas for finding the expectation of the random variable, mean of the random variable, variance of the random variable. Similarly, here, so we have to write the formula for finding the expectation of the continuous random variable. So here expectation we are defined in that way. So here we are writing sum of x. So here continuous means we have the interval over minus infinity to infinity. So x into here the probability function is you can define as p of x, here f of x into d of x. So next one, expectation of x square is nothing but minus infinity to infinity x squared into f of x dx. Then mean equal to same thing, expectation of x, variance equal to expectation of x squared minus expectation of x whole square. Okay. In both of the case, mean and variance same thing. Okay. Formula is same. Okay. So clear? Actually, discrete means the corresponding probability function is defined as, that is called a probability mass function. Okay. So continuous means the corresponding probability function is called denoted as f of x. So this is called a probability density function. Already explained in the previous class. Okay. So therefore, so these are the formulas for getting expectation of the discrete random variable, expectation of the continuous random variable. Okay. So clear? So this is the formula for getting that one. Now we move on to the problem for the mean and variance of the discrete and as well as continuous random variable. So clear?
Yes, sir.
Okay. You just copy the formula. So now we move on to the problem.
Sir, probability part is over.
Probability, actually today, apart from that, we look at one more topic, that is moment. Okay. So it will take only the half an hour. Okay. So after that, the probability, that is random variable concept is over. Okay. So today I will try to complete all the random variable concepts. Okay. So next class we have to discuss some basic probability problems. Okay. Almost we got to try to complete unit 1. Try to reach to completion of unit 1. So now I have write one problem. Okay, so now look at this problem. Actually, here one distribution function of a random variable capital X is given. This is nothing but capital F of X. So in your given statement, CDF of the continuous random variable. Here interval is defined x greater than or equal to 0. So CDF of X is given. Okay, cumulative distribution function of the random variable is given, F of X. CDF of X is, that is nothing but F of X. Okay, so cumulative distribution function, CDF means cumulative distribution function of a continuous random variable is capital F of X, that is given in the problem. So our aim is we have to find out density function to find probability density function. Okay, to find PDF F of X. Okay, so find here the question asking probability density function. So therefore we need to find out probability density function. Then we have to find out mean and variance, as well as we have to find out these things. Okay, so the given problem, the cumulative distribution of the random variable is given, capital F of X given. So we need to find out these things, PDF of the cumulative distribution function, and mean of the, after getting F of X, you should find out mean and variance. Okay, so how to get that one? So we know that formula CDF of, so continuous random variable capital X is, what is the formula? Capital F of X equal to, what is the formula here? Minus
infinity to X fx dx
minus infinity to
is equal to 1.
F of X dx. Okay, so this is the formula for finding this is a cumulative distribution function of a continuous random variable. This is the formula. So using that formula, so we have to find out small f of x. How it is possible? How it is possible? Now this is the formula for CDF, cumulative distribution function. So here capital F of x is given. Okay, now we need to get small f of x. So this is the formula for CDF of the continuous random variable. So using this relation, so we try to get small f of x. So how to possible? If you are differentiating both,
We
yeah,
are differentiating both sides and equating to one.
you are differentiating both sides means this integration should be cancelled. Okay, so therefore easily you can get that one. Okay, so now we are differentiating both sides means d by dx of f of x. Okay, that means I'll write this side. So d by dx of f of x means if you are differentiating here, d by dx of f of x is nothing but you are getting small f of x. Clear? This is clear,
Yes,
Abba?
sir.
Now we are differentiating both sides with respect to x. So therefore, differentiation, integration cancel, you are getting this relation. Okay. So therefore, this is your f of x. Okay. 1. This is minus 1 into e power minus x. Okay. Then minus x into e power minus x. Okay. So now you are to differentiating this function with respect to x. So d by dx of f of x. What you have to get? 1. Okay. Minus e power minus x plus differentiation is e power minus x. Here you can apply product rule x then minus. So minus x into e power minus x. So keeping u and differentiating v, then e power minus x, then differentiation of x is 1. Okay, so you can differentiate here. Now simplify that one. So here that is plus, this is plus, this is minus, that is cancel. Therefore, you are getting 1 plus x into e power minus x. So this is nothing but f of x. Okay, so this is nothing but f of x. So this is your cumulative distribution function. The condition is given. It is valid only for x greater than or equal to 0. Okay, so therefore, so this is your small f of x. Okay, so this is your small f of x. So after getting, this is your density function. So after getting this function, so we have to find out mean and variance. If you want mean means before that we have to find out expectation of x and expectation of x squared. Then only we need to get mean of the random variable and variance of the random variable. So clear? If you have any doubt for up to this, for getting small f of x. If you have any doubt?
Sir, d by dx of 1 will be 0 now, sir. D by dx of constant will be 0, right, sir?
Yeah, sorry. Constant differentiation is 0. Therefore, you are getting only these things. X into e power minus x. Sorry. So this is your f of x. Okay. So now we have to find out expectation of x. Okay. What is the formula? Minus infinity to infinity x into f of x dx. Okay. Minus infinity to infinity x into f of x dx. So here minus infinity to infinity. Okay. Before that, your function valid from only this interval. Okay, x greater than or equal to 0 only. Therefore, so we can't directly substitute here. Therefore, this interval splitting into two parts, minus infinity to 0 and 0 to infinity. It's correct? Because this is valid, already defined. Capital F of valid for x greater than or equal to 0. That is also satisfied small f of x also. Okay, so therefore x greater than or equal to 0 means we can't substitute directly here. Therefore, we can split up the interval minus infinity to 0 f of x dx, then 0 to infinity f of x dx. Okay, so now we can in this interval, your function becomes 0. Okay. So function not defined. So therefore, you can consider as 0. Only here only the function is defined. So therefore, 0 to infinity. Okay. So here x, what is your f of x? That is nothing but x into e power minus x dx. So now you are getting 0 to infinity x into x square e power minus x dx. So how to integration that one? So how will integrate?
Integral UV formula.
Yeah, that is the UDV formula. What is the formula here? Integral of UTV means that is UV minus U dash V1 plus U double dash V2 minus U triple dash V3. You can expand how many terms exist. Up to this, you can extend the formula. Okay. So here, what is U dash, U double dash, U triple dash? So that is U dash, U double dash, U triple dash. That is the successive differentiation of U. And V1, V2, V3 is successive integration of dV. So we need first try to fix U, then try to fix dV. Then you have to differentiating this one. You are getting like U dash, U double dash, U triple, U double dash, U triple dash. If you are integrating this one means you are getting V, V1, V2, V3. Okay. So how many tests? So here, what is U and how to fix U and V? You know the Eilert procedure, no? Using the Eilert procedure, you can fix your U and dV. Okay. So here, what is U pa? Accordingly, Eilert procedure, which one is first come? That is the algebraic function. So therefore,
X
you are
square.
fixing U,
X
U
square.
equal to x square. After that, the exponential function coming into the Eilert procedure. So therefore, dV equal to e power minus x. So now we are differentiating this one. U dash, you are getting 2x. So U double dash, you are getting 2. Then U triple dash, that becomes 0. Okay. Here you can integrate here. So V equal to minus e to the power minus x and V1 plus e power minus x and V2 equal to minus e power minus x. So the formula existing up to U double dash V2, therefore you can stop this up to this. Now you have to write the formula here. U into V minus U dash into V1 plus U double dash into V2, limit from, what is the limit here? 0 to infinity. Now you are substituting this. What is U? U equal to x square. What is V? Minus e power minus x. Therefore, you are putting in front of this. So e power minus x minus U dash. So U dash into V1. So minus 2x into e power minus x plus U double dash into V2. Again, minus 2 e power minus x. So limit from 0 to infinity. Now you are substituting your upper limit and lower limit here. Okay. So what is your upper limit? Infinity. If you are putting x equal to infinity means e power minus infinity. That's why e power minus infinity value become 0. Okay. E power minus infinity value is 0. Therefore, all your upper limit becomes 0. Now substituting your lower limit. If you are substituting x equal to 0 means here 0, here 0. Only this term only exists. So therefore, what is your here? E power 0 value is 1. You are getting only 2. So this is your expectation of x. After substituting that limit, you are getting expectation of x equal to 2. Okay. So it is clear? Any doubt for expectation of x? Someone respond?
No, sir.
Okay. Now we move on to expectation of x squared. Then only we are try to get variance. Okay.
So it
So what
would
is
be
the form?
minus 2.
Huh?
So
How
it
to get
would
if
be
you are
minus 2.
if you are substituting lower limit means one minus sign exists, no? Already you
Oh,
having
yes,
minus,
sir.
the minus into minus plus. Okay. So now expectation of x square. So what is the formula here? Minus infinity to infinity x square f of x dx. Okay, x squared f of x dx. So already you know that f of x valid only for 0 to infinity, only that interval. So you can rewrite the limit. So 0 to infinity. So f of x is nothing but x into f of x into e power minus x. Already you having x squared, therefore x cube e power minus x dx. So here also you can follow the Euler procedure. So what is u? X cube here, u equal to x cube, you are getting 3x square, here you are getting 6x, here you are getting 6, then u4 equal to 0. Okay, here v1, so you can write up to find out v3, you are getting e power minus x. Therefore here formula existing, u into v minus u dash v1 plus u double dash v2, okay, then minus u triple dash v3 limit from 0 to infinity. Okay, because u4 0, you can write up to u triple dash v3 only. Now you are substituting u and v. Okay, so here what is u? X cube, v equal to minus, so minus x cube into e power minus x. Here u dash 3x squared of v1 is this one, so minus 3x square e power minus x. Then u double dash 6x, v2 equal to minus. So here 6x into e power minus x. Then minus u triple dash, so minus 6 into e power minus x. Limit from here 0 to infinity. Here also all the terms are involving e to the power minus x. If you are substituting x equal to infinity, means you are getting e power minus infinity. Therefore all upper limit value, all the term, okay, if you are replacing the upper limit instead of x, you are getting upper limit value 0. Now you are substituting your lower limit. Here x, you having the first term x, therefore this is 0. If you are replacing x equal to 0, means this is also 0. Here also you having x, that is also 0. So here e power 0 1, you are getting minus 6. If you are substituting lower limit on minus sign x, is minus into minus, you are getting plus 6. Okay, so this is expectation of x, this is expectation of x square. Okay, so this is expectation of x, this is expectation of x square. Okay, clear? Now you can write the formula for mean and variance. So what is the formula mean? So the mean of the random variable is nothing but expectation of x. Okay, so expectation of x is here, what is that? 2. Okay, and variance, you can write variance formula, expectation of x square minus expectation of x whole square. So expectation of x squared is here is nothing but 6 minus expectation of x is 2 square, therefore you are getting 4. So 6 minus 4, you are getting 2. Okay, so this is the way for getting mean and variance of the given random variable. Okay, so this is continuous case, that's why we can apply this formula. If you are having the discrete one, means you can apply the corresponding discrete formula. Okay, now move on to another one problem. Okay, now we move on to the another problem. So write the next problem. So the random variable capital X has the following probability distribution. Here X, then corresponding probability values are given. Okay. So here easily you can identify. So this random variable is represented as a discrete random variable. So okay, you can apply the corresponding discrete formula. Okay. So here you have to find out the value for K and mean and variance of the random variable. So one by one you can do. Already you know that very well. So you know very well. So therefore you can find out the value for K, mean as well as variance. Okay. So one by one you can do. So how to get the value for K?
Sum of all probabilities.
Yeah, sum of all probability values that should be equal to 1. Using that condition, you can easily get the value. Okay. So sum of all your probability values is equal to 1. Therefore, you are getting 0.4, 0.6, then 0.9. So 0.9 plus K equal to 1. So therefore, K equal to, that is 0.1. Okay. So therefore, this is nothing but 0.1. Okay. So next one, expectation of X is nothing but sum of X into P of X. Okay. That X value, then corresponding probability value. So therefore, minus 2 into 0.4, then minus 1 into what is your K value? 0.1, then 0 into 0.2, then 1 into 0.3. So what is your answer? Expectation of X.
Minus 0.6.
Okay. Minus 2. Okay. Minus 0.6. Okay. Next one, expectation of X squared. So expectation of X squared is nothing but sum of X squared into P of X. So sum of what is your X squared? If you are squaring all your X values, therefore you are getting that means 4 into 0.4, here 1 into 1 into 0.1.
2, sir, 2.
Okay. 0.2, here 1 into 0.3. What is the answer?
2, 2, 2.
2. Okay. It's correct. Okay. So therefore, you can write mean equal to expectation of X. So expectation of X is minus 0.6. So what is variance? expectation of x square, expectation of x whole square. So expectation of x squared is 2 minus expectation of x equal to minus 0.6 whole square. So what is your answer? So what's your answer?
Minus 1.6.
Minus 1.
1.6.
Minus 1.2 or
6, sir, 6.
2 or 6. So minus 1.6. Okay, bro. Actually, in the previous class, I was given one homework problem. So all are completed.
Sir, tell the assignment question, sir. Question number 1, sir.
No. Actually, that problem is you having the function. One probability distribution is given x into e power minus x squared by 2. Completed, huh? Okay, I just recollect that one.
Yes, sir.
Okay, so this is the simple concept, mean and variance. That is over. Okay, in that way you are doing. In the examination point of view, we are asking that. So mean and variance means you can identify whether it is discrete and continuous. That case you can you can apply that corresponding formula. What is that?
Sir, tell the first question of assignment, sir. First assignment question, sir.
Fourth.
First assignment question, sir. You have given assignment. The first question. So tell us the first question, sir.
11 बजे के बाद.
Okay. So actually the problem is completed or not? Your homework problem.
No, sir. First. No, sir. Yeah, homework is completed, sir. That first, the assignment is which you have given to submit, sir. Tell me the first question, sir.
You want the question of assignment? Yeah. Okay. Actually, that problem you have some mistaken. Actually, the probability taking the values for 12, 13, 14, that is not correct. So the correct one is 1 by 2, 1 by 3, 1 by 4. Okay.
Then after, tell the way to proceed, sir.
No, I'm not having that assignment question here. 1 minute, I will take it.
दुकानों पे जाके मिलेंगे.
उसमें तो सबसे बढ़िया यही बता.
लीफ वेल पे. मैं तो अपना वो मंगवा रहा हूँ. वाटर बेड वाला पिलो. वाटर पिलो रहता है.
Okay, so after solving that problem, I will post in your GCR. Okay, right now I am not take that. One minute. Mute. Someone is stepping mute.
सरसों वाले लेक में वही हाल
Yeah.
उसका है जो तुम्हारे छोटे छोटे पे लगाते थे, मंगवाया वाटर।
So this is also assignment question, no? Hello, student. So this is
No,
also
sir.
your
This one is
assignment.
not. Okay,
This
sir.
is not
Sir,
an
we
assignment.
have done, sir.
Okay, you are done. There is no doubt in this problem.
No, sir.
Okay. Actually, your batch one students are asking so many doubts. It's in this case. That's why I'm trying to solve them. Okay, if you are solved now, no problem. We can move to the next one. Actually, gain and variance over. So here, because in your examination pattern is asking, we are asking only the MCQ pattern. So this time in your CT1. So that is your test one. So here, continuous random variable, the corresponding probability density function is given in the program. Some of the condition is given. So this is your first condition. This is your second condition. Using these two conditions, you will be getting the value for A and B. Okay. So in that of model, we have to ask the questions.
The sound is not clear, sir.
Today first condition is
The sound is not good, sir. It's not clear.
uh, probability of probability of so your function defined f of x equal to 3x squared in the interval 0 to 1. Okay. So how to write that one? Probability of x less than or equal to a means how to write that one? Here also x greater than a.
Integral 0 to a on left hand side.
Actually, here point 0 to 1. Okay.
Integral 0 to a on the.
My voice audible?
No, sir, your voice is not clear, sir. No, sir, it's breaking.
I'm not able to hear your voice in your side.
Sir, your voice is not clear, sir.
Hello.
Sir, you are not audible, sir.
Vishek.
Sir, your voice is not clear, sir.
Vishek.
Your voice is not clear.
वो भाई साड़ी चलेगा
चलेगा रिकॉर्ड हो रहा है रिकॉर्ड हो रहा है
Okay. So now it is okay. Okay. Students. Hello.
हाँ सर यस सर यस सर
Okay. Now it is okay. Okay. Now how to write that one? Probability of x less than. So this is one of the condition is given in the problem. So using that in that condition involving the constant a. Okay. So how to get that value for a? So how to first of all how to write this one? Probability of x less than or equal to a.
minus infinity to 0, 0 to.
Minus infinity to 0 and 0 to a. Okay, clear? Minus infinity to 0 and 0 to a. Actually, so here we have the minus infinity. This is 0. So this is infinity. Okay. So x less than a means we have to write minus infinity 0. Here we have the point a. Okay. 0 and a. So therefore, you can write up that minus infinity to 0 and 0 to a. Okay. So we don't know the value for a first of all. So we don't know this is you have to find out that one. Okay. So we don't know the value for a. So therefore, minus infinity to 0 means here this function valid only 0 to 1. Okay. First of all, 0 to 1. So therefore, minus infinity to 0 function not defined. So now 0 to a we are considering only 0 to a because we don't know value for a. Okay. So a becomes you having that is 0.5, 0.6, 0.7, you may get something. Okay. So therefore 0 to a only we are able to write that interval 0 to a. Okay. So 0 to a. Suppose if you are considering a value becomes 0.1, that is 0.1, 0.2, 0.3, 0.4 means what is your function value here? This is 0 to a, you are writing f of x dx. Okay. x greater than a. X greater than a means how to write that one?
A to 1.
A to 1
One.
and 1 to infinity. 1 to infinity. Okay, so therefore you are writing a to 1. Okay, because also here function defined this only. So this is infinity. Suppose I am considering this one is 1. Okay, so we don't know a involving. So a to 1. Okay, so a to 1 f of x dx. Okay, so 0 to a means we don't know the value for a. So a becomes 0 to a means up to 0 to 1, your function value become 3x squared. So therefore, 0 to a, f of x equal to 3x square dx. Then a to 1. So this function value up to 1. Okay, a you are considering a is a positive 1. So therefore, a to 1, that is also 3x square dx. Okay, 0 to a. So here 3 x cube by 3 limit from, okay, 3 x cube by 3 limit from 0 to a. Here also 3 x cube by 3 limit from a to 1. So here 3 cancel, here also 3 cancel. Okay, so what is the answer for that one? A cube. If you are substituting your upper limit, a cube minus 0. Okay, so here also your upper limit is 1 minus a cube. 1 minus a cube. So therefore, 2 times a cube equal to 1. So therefore, a cube equal to 1 by 2. Okay, so a cube equal to 1 by 2. So therefore, a equal to 1 by 2, 1 by 3. Yeah. Okay, something you are getting?
0.798, 0.793.
8 to 1. Sorry, 2a cube. Sorry, a cube equal to 1 by 2. Okay, a equal to 1 by 2 power 1 by 3. No need to convert that one. You can keep it here. A cube equal to 1 by 2 power 1 by 3. Okay, so in the way, similar way, we are getting x greater than b. Second condition using say. So no need to convert that one. So this is your a value. Okay. Similarly, we can write so probability of x greater than b. X greater than b equal to 0.05. Okay. So how to write x greater than b? Okay.
B.
So in that yeah. If you are here a, this one is b. So this is 1. So this is infinity. Okay. So how to write that one? X greater than b means b to 1 and 1 to infinity. Okay. So you can write b to 1. X greater than b. F of x dx equal to 0.05. Okay. So therefore f of x equal to here b to 1 3 x square dx equal to 0.05. You can integrate in that one, you are getting that value. So therefore, x cube by 3. So x cube limit from b to 1 equal to 0.05. So what is the value for b? So what is your value for b?
(0.95 to the power 1 by 3).
Yeah. So b value becomes
0.983.
0.983 or 1 by 3. Yeah.
No, sir.
0.95 to the power 1
Final
by
answer
3
is
is equal to
0.983.
Only 0.983. Sorry.
final answer.
Okay, final answer. So 0.983. Okay, so this is your a value. So in the way you are finding that A and B value. Okay, so almost random. We so far we have discussed so many problems for the random variables. Okay, almost completed the random variable portions. Except one of the topic is there, that is the moments. Okay, so it will take only 15 minutes, 15 to 20 minutes. Okay, moments. And from the beginning we have some discussed. So we have to one of the main concept is Bayes theorem. Actually, that is come in the front of the front of your syllabus, unit 1 front. So therefore, the next class onwards, we have to discuss Bayes theorem. So remaining, we have two topics: Bayes theorem only and moments. Okay. So unit 1 is over.
Sir,
Okay,
send the assignment, sir. So send the assignment solution, sir. Question number 1 solution of assignment.
Okay. After completing that class, I will post in the solution of first problem of assignment question in your GCR. Okay. So I will post
We
the
have CT, sir.
solution. Okay.
We have CT, sir. Send it before, sir, before the completion of course.
Yeah. Okay. Everything I'm going to be upload here. So I will upload. Already one PPT uploaded, no? You are
Yes,
able
sir.
to.
Yes, sir.
Yeah.
Yes,
Okay.
sir.
So PPT uploaded. So today we have to upload all materials. Okay. So what are the remaining materials are there? Everything I have to post today. Okay. I will post it in your GCR. So you don't
Okay.
problem. So you don't wait up to the class time. You can ask anytime. We have a WhatsApp group. Okay. So you know my number. Okay. So don't wait for the class. You can ask. You can ask at any time, or if you are if you have any question, you can post the GCR also. So I can answer all those things all the ways. Okay. Okay, but number 1, present or absent.
So 65. 165, sir.
Yeah, number start from 165. So actually,
No, sir.
65,
okay,
sir.
actually,
Only
okay. All are,
65, sir.
yeah, all are present. No, okay, no problem. I will try to. Okay, ba. So apart from that, if you ask any question now, you can ask.
Okay, sir. Bye, sir.
Okay, but thank you, students. So up to this, you don't have any doubt.
No, sir.
No, sir.
No
Okay,
doubt, sir.
So send the
okay.
recording, sir. Sir,
Yeah.
send the recording, sir.
Yeah, this
Recording
recorded.
of this class.
Yeah, okay. Yeah, surely I will.
Okay,
Okay,
sir.
sir.
Bye, sir.
Thank you, sir. Bye, sir.
Students, thank you, students. We'll see you in the next class. Okay.
Thank you. Yes, sir.
Thank you.
Yes.